Hello again everybody, and welcome back. This is the fourth video in our six-part video series on character recognition and license plate recognition in OpenCV 3. And in this video we're going to perform license plate recognition in C++. So let's go ahead and dive right into it. So if we go to GitHub, microcontrollers and more, and then we take out the spaces, and then we're going to go here, and then we're going to go to repositories. And I should first mention some prerequisites for this video today. If you go to this repository here, OpenCV 3 Windows 10 installation tutorial, and then definitely I would suggest checking out this playlist linked to up here, and then following this first video here, OpenCV 3 Windows 10 installation tutorial part 1 C++. And the other prerequisite for this video today is going to be the first video in this six-part series, which was this here, OpenCV 3 KNN Character Recognition CPP. And what we did in that video was perform character recognition, and specifically we generated classifications.xml and images.xml, and those same two files we're going to be reusing today. So let's continue on with today's project, which is OpenCV 3 License Plate Recognition CPP. And first we'll take a quick look in docs and presentation, and if we take a look at this document here, steps with images, this is sort of a quick overview of the algorithmic steps we're going to follow today. So starting out with, in this one example image that we're taking a look at here, here's our original scene, and then we pre-process that to get a grayscale and a thresholded image. And then we find all the possible characters in the scene, so that's effectively all the contours in this thresholded image, which in this example of this particular image happens to be 2,362. And then we're going to find all the characters that are, or all the contours that may be characters out of this 2,362, and that gets us down to this vector of 131 possible characters here. And to go from the 2,000 sum to the 131, that's a matter of not of comparing the characters to each other yet, we'll do that later, but first that's just looking at each contour in isolation and making sure it has a minimum width, a minimum height, the aspect ratio is within a certain boundary, and some other characteristics that we'll take a look at later in code. But continuing on here, the next thing we're going to do is, looking at these 131 possible characters, we're then going to come up with groups of matching characters within that 131 possible, and that's what we have in this next image here, and the characters are color-coded. So for example, these three purple are a possible, are a group of matching characters that could end up being a license plate. Of course that doesn't end up being the license plate, but we don't know that until the end when we apply the character recognition. And then these seven characters, that obviously ends up being the plate, and then you can see there's some other matching groups of characters as well here, like these three teal ones to the top right, these three dark green ones, these two light green ones, and so on. And then what we do next is we call extract plate, and then that's going to give us our 13 groups of characters as possible plates. And then at that point we essentially some of the steps that we followed so far in the first half of the program, we're going to repeat those in the second half of the program within each plate instead of the scene as a whole. So for example, to trace through the second half of the program here, I've taken as an example this image, which ends up being, of course, the actual plate, and this image, which is, I believe, this area in the trees at the top of the image here, which of course does not end up being the actual plate. So what we're going to do is we're going to call pre-process on each of the 13 possible plates, and that's going to give us our grayscale image and our thresholded image. Then we're going to call find possible characters in plate this time instead of possible characters in scene, but it's very similar. So that's going to get us essentially all the contours. Then we're going to throw out the contours based on size, aspect ratio, etc. without comparing them yet. We're going to throw out all the contours that couldn't possibly be a plate, that couldn't possibly be a character rather. Then the next thing that we're going to do is we're going to look at the remaining contours that are possible characters and find groups of matches. So for example, in this image on the right, which of course doesn't end up being the plate, there are 3 possible matches here and then 3 possible matches here. So there's 6 total, but only 2 groups of 3 matches each. And then of course the plate that actually ends up being the plate, all 7 characters are found to be matching. So then what we do is we take, for each of the 13 possible plates, so including the 2 for example here, we're going to find, we're going to call recognize characters in plate. So that's, we're going to find the MCLRN F1 in this left plate, and we're going to find these 3 contours over here that end up being recognized as the characters I1 and V, which of course are not actual characters. But what we're going to do at that point is, for each of the 13 plates, we're going to take a look at which plate has the longest string of characters that were found, and then we're going to suppose that that's the plate, and that's going to allow us to find that the MCLRNF1 here is the plate, and then we're going to write in yellow the plate itself, or the plate text I should say, just below the plate itself, and then we're also going to print it out to standard out. So that's kind of the logical steps we're going to follow in the program today. And I also made this document here, steps.png, which is just sort of more of a text-based, flow chart of the steps that we're going to follow, the data structures that we're going to be working with, the functions we're going to call, and so on. So if you'd like to follow along with the program, this chart may be helpful to you. And then if we go back a directory here, so here we have all our CPP and H files, as well as the classifications and images files that we generated in the first video in this 6-part series, where we did the character recognition by itself. And then we also have this directory here, license plate images, which is 16 images. So for example, the first one is that image we've already been looking at, and then there's 15 more images that you can test on, and so on, that have license plates and scenes. So that's sort of an overview of the repository, so let's go ahead and implement the program. Okay, so we're going to go ahead and fire up Visual Studio here, and while we're waiting for that, we're going to go to Download Zip, and then we're going to choose Open, and because there are the 16 images in there, that's going to take a moment to download, so then we're going to close this splash screen here and go to File, New, Project, and there the download just finished for us. So we're going to double click into the download here, and here's the GitHub repository contents. We'll come back to that in a moment, and then we're also going to take a look at the directory where we're going to be building the project today. So that's going to be Documents, Visual Studio 2015, and Projects, and we're going to go ahead and put it there. So let's go ahead and make the project now. So we'll just copy the repository name. That'll work well for the project name. So if we go to, let's see here, Visual C++, empty project, and copy in the repository name, take out the space at the end, choose our preferred location, go ahead and uncheck those, and choose OK. And that's going to go ahead and build the project for us. So here's our project directory now, and we can save ourselves some time by going to the license plate images directory and copying in the license plate images. And then we can also copy in, I believe, all of these except for the README. Let me just double check that here. Classification, CPPH, CPPH, images, CPPH, CPPH, CPPH. Okay, yep, that's good. So then we'll go ahead and copy those into the project directory as well. And then we'll go to the project here, and then we're going to go to Project, Add Existing Item, and then we're not going to add the images or classifications.xml or images.xml, but we're going to add all the CPP and H files. So those, and those, and then add. And then there's two locations we should take a look at here. So if we go to main, we can either comment out or not comment out show steps, depending on if we'd like to show the steps or not. And then we'll go ahead and run it both ways. I'll demo both ways for you so you can see the differences. And then we, in main, that we'll find, okay, we didn't do our references yet, so debug, and then we definitely want to set this to x64, and then we'll go ahead and put in our OpenCV references here. So Visual C++ directories, include directories, and edit. And that's going to be here. And again, please see the tutorial video I mentioned earlier if any of these configuration steps aren't especially clear. I explained pretty thoroughly in that video how to perform these steps, and then also have a cheat sheet, which is what I'm copying and pasting out of now to make the configuration steps as easy as possible. And then we're going to go to linker input, and whoops, and there's only one library that we need as of OpenCV 3.1, OpenCV World, and then OK, apply, and OK. Alrighty, now all our red underlines are gone, and this here is where we choose which image to work with. So now we're all set to go ahead and test run the program. So I'm going to go ahead and press Control F5. And it's going to take just a moment to load, and then we should see to build a project and then run it, and we should see our license plate. There we go. So 13 possible plates found, and there's our text read from our plate, and here's our image, and of course we've drawn a red box around the plate, written the plate in yellow, and then here's a crop of the plate, and then here's a threshold of the crop. So that worked out well for us. So let's go ahead and run it with the show steps option uncommented so we can see the steps. So Control F5, And I'm going to try to arrange all the windows within the screen as best as I can here. Let's see, so maybe if we move the command line way over here, and then if we take a look at image 0, so this is our original image, and this of course is our grayscale image, and then our threshold image, and then this is the image with the 2000 some contours, and this is the image where we've worked our way down to the 131 contours, and I'll show the actual criteria that does that next here. So if we go to detect characters, and it's not too far in, I believe, find possible, check if possible character. Yes, it's this function here, check if possible character, takes us from the 2000 some contours to 131, and we're simply checking for a minimum pixel area, a minimum pixel width, a minimum pixel height, and then an aspect ratio within a certain boundary. So that gets us from that 2000 some contours down to the 131. And then we have our next function. Let's see here, if we go to detect plates, where we call, let's see here, preprocess, find possible characters in scene, and then we call this function here find vector of vectors of matching characters. That's what takes us from this 131 down to this list of lists of 13 possible plates. So then we're going to go to, and we've already begun the second part of the program here, or rather, we're still in the first part of the program, but we've already drawn an outline around one of the plates. And then this is simply a crop of the plate that's found. So now if we click on the image and press a key here, and I'm going to try and stagger these windows so we can see things as much as possible. Okay, so there's the second possible detected plate, third, fourth, fifth, etc. So that's simply drawing a box around each of the sets of matching characters. So now the plate detection is complete. Now we're going to launch into the second phase of the program, which is essentially performing a similar set of steps but on each possible plate. So of course it just coincidentally so happens that the first plate detected is the one that ends up being the actual plate. But if we look through the rest of them, so there's 3 what was found to be matching characters. Again, obviously those aren't actually characters. In that plate I believe there weren't any, and neither in that plate. And in this plate here we have 3 possible characters, and 3 possible characters, and 3 possible characters. So you'll notice we haven't had as many as 7, which was how many was in the actual plate. So we can be pretty confident if we simply pick the longest list of matching characters, that's going to get us the actual plate. This one here gets a little close. That's 6 matching characters, I believe, 3, 4, and so on. But eventually we're going to see that out of the 13 possible plates, the longest number of actual matching characters found within any of them did turn out to be the McLaren F1 plate. So that worked out pretty well for us. So let's see, it does take quite a bit to go through the program showing all the steps, so let's go ahead and comment that back out. And then we can go back to main and we can repeat that on just a few of the other images. So here's image number 2. And of course these are all vanity plates that I found on the internet here, so LOL Watt. And then we can go to the third plate and so on, and this program doesn't work absolutely perfectly. O's and zeros, and then also ones versus L's versus I's can be very font dependent. Ones versus I's especially can be font dependent. So for example, this says RIP LS1, and here we're reading it as RIP LS1. So there we just happen to get the I and the 1 read correctly, but sometimes I's will be read as 1s, 1s as I's, and sometimes O's as 0s, 0s as O's, because those are font dependent. I would still consider that a successful read. You'd really have to make the program specific to within a certain state, or have knowledge of specific states to get down to the point that you could separate those characters out. And there are a few cases where some characters will be missed. This isn't really a full production grade ready program. For example, in this plate here, NICESKY, the K is the I is read as a 1, as I just mentioned. I's and 1s are very font dependent, difficult to separate those out. And then we have the K that's missed, and you can see the reason for that is that our thresholding algorithm put a slight cut in the K here, and the left side of the K and the right side of the K alone were found to be too narrow to be a character, so the K was missed altogether. But again, although this program isn't necessarily perfect and doesn't read every character, as you can see for the most part it works pretty well. So here we have NVSBLE, there's a perfect read, and then we can just test a few more of these, 6, and NYSJ, that's a pretty easy one, but still we'll take it, and then we'll just do a few more here. So there's 7, there are 16 total images, I don't think it's necessary to go through them all. So ANBYOND was read, I can't get it off the top of my monitor, the screen's a little too small here. And let's jump on to number 8 here, and then 1Z, so you can see the M is misread as a P, and then 961, but we do have a very good job here that our program's done as far as the plate is clearly at an angle, but if you look at our result, we've managed to flatten the letters out, so our correction as far as the angle is working pretty well for us. And we'll just take a look at one more here. Go ahead and fire it up, and there's number 9, PNY EXPS, PNY EXPS. So I think this works out pretty well. Not quite production grade, but pretty close, and definitely a good starting point for anybody interested in learning about license plate recognition. So I would say that was successful, and in the next 2 videos we're going to implement the same program in Python and then in Visual Basic. So see everybody in the next one.